Maybe. All right. So if you were with me first semester or any of the science teachers first semester, we touched a little bit on a review of the rock cycle at probably in December. And so you have your three rock types, your igneous, your sedimentary, your metamorphic. Your igneous rock is what comes straight from the magma and lava itself. Sedimentary rock is any type of rock that gets like broken down, usually into like sand or pebbles or something, and then kind of re-cements itself together through pressure. And then metamorphic rock is when any type of rock gets changed due to heat or pressure from kind of being buried or close to a magma source. So there's kind of your general review of that. All right, let me pull this up as a little bit bigger. I'm gonna have you guys solve this puzzle. So someone took the last cookie in the cookie jar last night. The last person to leave was the culprit. Who was that person? Your clues are the butler walks to work, your handyman rides a bike, the cook rides a motorcycle, the nephew has a seeing eye dog, and the maid drives a car. So using the picture to the left, think about, and then it tells you to draw. You can just circle or write who you think is the guilty one. So take a minute or so to solve this crime, especially if it was Girl Scout cookies. This is a big crime. Who do you think was guilty? Maybe. Are you editing your answer? Bless you. All right, waiting on 2 more people to submit. Who's my non-submitter? Star, I know you have your answer. You gotta hit submit. All right, we're gonna see how people voted. All right, the nephew with the seeing eye dog. Nephew with the seeing eye dog. Everyone split it. Otherwise, they voted for the handyman. The dog itself ate the cookies. The cook who rides the motorcycle. And another vote for the nephew with the seeing eye dog. So, hold on. Anthony, do you want to tell me why you picked the nephew with the seeing eye dog?
No.
No? Why not?
because all of the tracks are um, recent.
Good. How do we know they're recent? That's a perfect answer.
Because they're old, the tracks are old and tracks.
Beautiful, Akil. All right, so because the nephew and the seeing eye dog, their footprints or their tracks are overlaying other tracks. So there's my mouse. So, like you could see, the dog had stepped in the footprint of the butler, so we know they came after the butler. The butler stepped on the motorcycle tracks, the tire tracks, and the bicycle tracks. So that means the butler would have been the second to last to leave, making our nephew with the seeing eye dog a very guilty thief of stealing the last cookie. And that, what you just did there, is exactly what we do with rocks and how we put them in order. So if you can handle this, you can handle some relative dating. All right, let me get out of the big picture. Very nice, guys.
Good job.
All right, I don't think you have any writing to do these first couple of slides, but this is just explaining there's two main methods that we use in order to get an age of a rock. The first one is the one that we're going to talk about mostly today, is the relative dating, not the Alabama, Mississippi type. All right, it's just a list of order of events, not ages. So by me saying I am older than you, that's an example of relative dating. That means I was born before you guys were born, and that's our relative order of events. We're going to talk today about Steno's laws and unconformities. We won't get to the fossil succession quite yet. And then the absolute dating is one that we'll talk about probably next week or when we come back from break, is giving an actual age to rocks or events through radiometric or radioactive dating, dendrochronology, and some bars and some things like that we'll talk about. That one also involves a little bit of math. So we're doing the non-math version this week. Again, the relative dating just means identifying which rocks formed first, second, third. So we're going to practice putting things in order and including some sequence. We're going to do some easy ones today. We'll save the harder ones for next week. And then we're going to heavily rely on what's called Steno's laws. When you come up with these things, you get to name them after yourself, right? So before we move on to Steno's laws, tell me the difference between relative and absolute dating, relative and numerical dating. What's that? It's not moving for you? That is. Try doing that. I've never seen that happen before. There you go. Alright, I'm going to start peeking at your answers. Relative is not so much of a guess. We can actually gain a lot of information from it. It's just putting it in order. If I were to line you guys up by height, I don't have to do that with numbers. I could just look at you and estimate, right? Alright. Who put the IDK? Jose, IDK is not accepted in this class. Fix your answer. We just went over what they were. Very nice, Ashley. Alyssa. Fix your answer. You know what absolute is. Very nice start. Whoa, Keel's got the caps lock. I actually kind of like the summary. I haven't seen this yet. Very nice, Nathaniel, especially for jumping in. Jose, did you take your notes? Because the answers are right there. All right, moving on. So here is the 5 main stenos and a couple other laws that we'll talk about and use constantly. One of the most common go-tos is the first one, the law of superposition. All right, in undisturbed layers of rock, the oldest layers are at the bottom. So think of how dirty your bedrooms probably are right now, because what teenager has a clean bedroom? Do you really? I'm impressed. It wasn't me, I could tell you that. My stuff was everywhere. Yeah, I did too, but it didn't matter. Okay, imagine you have a dirty room, and throughout the week you throw things on the floor and or throw things over a chair or on your bed or something, and at the end of the week, the things you threw down on Monday are going to be at the bottom of that pile, right? And you throw stuff on top of it. That's the exact same thing that is going on with law of superposition, just with rock. All right. The law of original horizontality and the fourth one, the law of lateral continuity, I think kind of go together. So layers of sedimentary rock are deposited flat and they run continuous until they enter or encounter an obstacle. I tend to think of like trying to make a cake and pouring cake batter into a pan. It's going to go flat and spread out continuously until it hits the edges of the pan. So sedimentary rocks do the same thing. This third one we'll actually talk about and discuss today, cross-cutting relationships. So anytime there's something like intruding in the rock or breaking the rock, anything like that disturbs it, that rock is older than that event that happened, which makes sense, right? I can't rip a rock in half if I was like Superman. if the rock didn't exist. So any breaks or disruptions to it occur more recently than the actual rock itself. And the last one, this is probably the trickier one of all of them, is the Law of Inclusions. Fragmented rock within another rock type is older. If you see in the picture over here, the orange and the brown, you have fragments of orange rock inside of the brown rock, so therefore the orange rock is the oldest. Is that the heater making that noise? That's weird. All right. So we're going to talk about some of those disruptions. And that first, so unconformities is the fancy science term for it. That is anytime we're talking about an interruption or a break or a pause in the rock record. And you can think of it like a historical record. So we represent a period during which deposition stops and restarts, or stops and things get eroded and taken away, and then somehow the deposition resumes again. So it's kind of like a missing chunk of time. The symbol for it is typically that thick wavy line that you can see right here. The only one you sometimes won't see it on is the angular conformity or angular unconformity, and we'll talk about that later. The other two types we're going to talk about are disconformity and nonconformity. So many conformities. Everyone good? All right, the first one is the angular conformity. It's the easiest one, I think, to point out because of the angle of the sediment layers. You'll hear me mention this a couple of times. Sorry, do you need me to go back, Alyssa? Okay. There you go. Let me know when you're good. All right, so here's the angular one. It's where sediment layers get uplifted or tilted. They can get folded, kind of like if you put some pressure on some paper and it starts to fold up. Same thing happens to our sediment layers. So that's what you can see right here. A really good local example that I could point out 100 times in this unit is Garden of the Gods. That is sedimentary rock. That's why it's really sandy feeling and looking. And so sandstone. And it's been tilted up and uplifted because, believe it or not, we do have some magma and some activity of, well, volcanic activity below our mountain range in Pikes Peak and stuff. It's not like an official volcano, but we do have it. That's why we have hot springs and things like that. That's all heated by magma. So really good local example of this. Another one I can pull up a picture, I forgot to put it in here, is Sakar Point in Scotland. It looks really cool. It's right on the beach, super exposed. All right, quick little quiz. Hide so you guys don't cheat off each other. 4 multiple choice questions over the last few slides. Let's see how you do. Yeah, yeah. Give it your best shot. Like I said, we'll go over.
I got it right.
Did you?
Yep.
Almost there. All right, we'll reveal your scores. Very nice. I think this is the only time I've seen the first and the last one 100% right. All right, let's go over them. Good job on the law of superposition, where the bottom layer is the oldest. Law of original horizontality places layers of rock flat, like my cake batter example. And horizontal means this anyways, the left to right, vertical is the up and down. So that's another kind of word connection you can make with that. Rock layers must be older than the intrusion that disturbs them is cross-cutting relationships. So, and I think that'll make a little bit more sense when you see some pictures of it. And lastly, what is an unconformity? Just that interruption or break or pause in that rock record. Very nice. Oh, while you guys were doing your quiz, I pulled up the Scotland one, mostly just because I like the name of the rock. My stinking computer. All right. The Sakar Point in Scotland. So here's what it kind of looks like. You have your angular uplift right there, or your angular unconformity. I like that it's called the Silurian Greywacky. That's how they name the rock. Anyways, that's why I pull up this picture. And then you have your flat layers. You have conglomerate, which kind of looks like concrete, and then sandstone right above it, like the same stuff that's kind of in Garden of the Gods. So that's what it can kind of look like there. Oh, yeah, I got you. It's because you're underrated. All right. So this is kind of how an angular unconformity forms. So you get your regular sedimentary deposition here, just like we did here in Colorado, when Colorado used to be completely underwater. It was part of a sea, part of the ocean. And that's why you have your like ocean fossils at Garden of the Gods and Red Rock open space. You can find those there, even though we don't have an ocean here anymore. So you get your sediment layers deposited. You get some sort of folding or uplifting event. So whether it's like magma chambers kind of growing and pushing the earth up, or compression kind of folding it up. And then you get some erosion going on. That could be from wind, it could be from water, Water is highly erosive, actually. Rivers, lakes, rain, any of that, streams. And then water comes back in and starts depositing new sediment layers. And so you can see the dark squiggly line here. The top of the little hill or mountain has kind of been chopped off, and new sediment has laid in. Here's another example, a little one more local, I guess, than Scotland, is Socorro, New Mexico. And so you've got your angular right here, and then you've got your flat layer that came in on top. So all of this was kind of like decapitated, and then the flat layer was able to deposit again, because New Mexico was also part of an ocean at one point. All right, our next one is the disconformity. A disconformity is where we have sedimentary layers separated by an erosional surface. So we don't have any tilting or folding or uplifting on this. You just have sedimentary layers stacked on top of each other. One of them might get like eroded away from that wind and rain, and then a new layer comes back on top of it. So it kind of looks like there's a layer that's missing. And we actually know that because we have basically what's called a geologic column, which is a global answer key to where every rock should be from like any given point in time. So they've built that global column, so we know if a rock layer is missing or not. In this image, we've got sandstone separated from limestone by some sort of erosional surface. You could have had like maybe a river coming through at one point, or a whole bunch of wind. Maybe it turned into a desert or something. Wind swept everything away, and then it started depositing again. Here's an example. You'll see a lot of Grand Canyon in this unit because it's so much exposed rock that we can easily identify. So you have a disconformity between the sandstone up here and the shale down here. Shale is a very brittle rock. You can almost like peel it apart. So that's why it kind of looks like it goes in chunks because it's pretty brittle, breaks easily. And then your disconformity would be this boundary line right here. Something happened because it just suddenly changed from one to the next. All right, our last unconformity is the nonconformity. It separates metamorphic or igneous rocks from sedimentary rocks. So the orange, igneous rock in here, in the inclusions. So this would kind of be like a nonconformity boundary. And then we have our sedimentary rock, our rock, shale, and limestone right above here. This should say nonconformity Grand Canyon, but of course Nearpod likes to cut off my slides. So this is another view of the Grand Canyon. You have your schist, Vishnu schist, topped by sedimentary, just different sedimentary rocks. Schist is a metamorphic rock. So it gets heated up. It's another one that's really brittle. And then you can tell these are sedimentary because they're laid down in those flat layers. So here's an example with all three of the unconformities kind of combined. From the Grand Canyon, we have our river of the Grand Canyon right down here. We have our angular unconformity, where we see that our layers have been tilted up, possibly tilted up by this nonconformity of granite coming up and trying to make room for itself, pushing it out of the way like you push your little brother and sister out of the way. Especially Ashley, she's pretty violent. And then you have your disconformity, which is, remember that missing deposition like we saw with that other Grand Canyon picture. where it had the shale and the sandstone. So examples of all three of them in one. And I've also have your time periods, so your Permian, Pennsylvanian, Mississippian, Devonian, Cambrian, Precambrian. All right. I'm going to assume nobody remembers their volcanic-related vocabulary from middle school. So igneous intrusions are also called plutons. You'll see it referred to both ways. They're kind of synonymous. Down here we have a big batholith. That is like a massive, massive amount of magma, like close to the mantle. Anytime it tries to sneak out of itself, so it heats up and weakens rock and makes a way for itself, those are called a dike. All right, if that dike expands and makes itself a happy home, it becomes a pluton, which is this one right here. And then when it comes up in between separated layers, you get a laccolith. When it comes up and just kind of sneaks out and makes like a sideways dike, those are called sills, like a windowsill. And then the stuff that we're more familiar with, all the way up towards the top of the surface, is your magma chamber. This is pretty much the only stuff that we have access to that creates your volcanoes, right? All right, so let me enlarge this. What you guys are going to do, and I'll point them out to you so it's easy, so you don't have to search for 10 minutes to find them, is tell me what type of unconformity feature X is, which is right here. It's that squiggly line. Oops, I almost gave you the answers. Which type of unconformity is feature Y? This one right here that goes across. Which unconformity is older? So you're going to tell me if X or Y is older. And then what is older between X and the batholith of K? So I'll leave the big picture up for a minute or so. You can type on your Nearpod, you can draw on your Nearpod, doesn't matter to me, but answer those 4 questions. Hi. They're only good for crappy facts. All right, I'm going to take down the big picture. quick. Those of you on the last question, Nearpod cut it off. It should say which is older, Unconformity X or Batholith K. So Unconformity X or Batholith K. Which one of those is older? Remember, batholith is that big chamber of magma way down below the surface. I love when it shows submitted, but it shows it blank. Good. Just waiting on a couple more submissions. We'll see how underrated Ashley does. Maybe. Don't worry about getting them wrong, because when you get them wrong, I can see where your confusion lies and try to fix it at least. Don't forget to hit submit. It looks like at least one of those might be done. Who am I strike with? There we go. All right. There we go. All right, I'm showing names so I can call some of you out. All right. All right, I like this one. So, Anthony, don't be scared. Which is older, Unconformity X or Batholith K? And you said K is older. Why did you tell me that? Okay, good. So that's one reason. The K is more on the bottom. The X is on the top. And we talked about the older being on the bottom. I'm going to enlarge this picture again really quick so you guys can see it a little bit clearer. Do you guys see how the K kind of gets decapitated right here by X and it stops from going any further? That also tells us that K is the oldest. So those two things, what Anthony said and what I added on, that decapitation is important. All right, very nice, Anthony. Jose, did yours? Oh, you put yours on top. All right, size does not matter. So K is older. You got that one. That's good. All right, underrated Ashley. I actually let you make this mistake because I wanted to talk about it. I know. All right, which type of unconformity is feature X? So X is this sideways. Ashley says angular. Does anyone else have another answer for that one? star would you get for this first one? What's that? Yeah, what type is it? Unconformity, or sorry, disconformity, nonconformity, or angular? This one right here. Good, it is a disconformity. All right, so I know what mistake Ashley made, and she's not the first or the last person to make it, is because it's tilted, our brains automatically think angular. But you got to pretend, like work yourself back in time, hit the rewind button, and show that at one point these layers were all flat, and that same event that decapitated the batholith right here, that is a regular disconformity. That's when something got eroded, or there's some time missing. So, star, you are correct. It is a disconformity. Which type of unconformity is Y? Ashley, do you want to change your answer? It is. And why? Why is it the angular unconformity? Oof. For Y, yeah. Good. We've got our folded, tilted up sedimentary rock, and then we've got our layers on top. See? Now you'll remember. And then let's go to somebody else's. All right, Alyssa, I'm going to pick on you even though you're online. It's okay. Which unconformity is older? You said X. Why is that? All I got was a big no. Tell me why you think X is older. You don't know, you just guessed. Akil, what about you?
X is more at the bottom.
Good, yeah.
And Y is at the top.
Beautiful. I love the answer. X is more at the bottom. It was before even the tilting and before Y could happen. There you go. All right. Very nice. Very nice, guys. There was the answers. I was sneaking them. All right, I'm going to go through this first one with you, and you're really going to have to bear with me on how well I can write with a mouse, and I'm apologizing now because it's bad. All right, so let me get my mouse pointer to type or to write. You guys can type it in yours. You guys can definitely put it in your notes too. So don't forget that. All right, so we're going to start looking at rock layers. They're going to increase in difficulty. So we're going to focus on this one on the left side. So I'm just going to draw a line right here. We're going to focus on this one right here. Bless you. All right, we have 3 different rock layers, and I've put a legend over here. So this tells us what kind of rock we're looking at. What might this bottom one be? Not quite. The one that looks like bricks. There you go. Very nice, Jose. Limestone. What's this middle one? That one is the sandstone. And the top one? That one's close. That would have little dots in between it. Good, Ashley. Shale. All right. So we've got our 3 different rock types. And what could this possibly be? Think back to our Grand Canyon pictures. What could that possibly be? Where are my Grand Canyon pictures? I'll just pull one up. Yeah, it was an erosion. I'm going to try and pull up a picture if I can find one very quickly that shows it very similar, so you can see what I'm talking about. Of course, I pull up Grand Canyon, and the first thing that comes up is how many people die at the Grand Canyon. Okay, that's lovely. Here's, I think, a good picture. So, oh, of course, and it's super tiny. Right. So we have our rock on the side and kind of this valley in between, and we've got what going through the bottom of this picture? Yeah, a river, right? So that is kind of what we'd be looking at right here. And that river is going to break down that rock, pick up those pieces that it broke, and move it downstream. All right, so that's kind of what we're looking at for that. So, unless otherwise stated, generally order this list from oldest to newest. So what is the oldest thing on this picture? Beautiful, good. I got a lot of limestone answers. Okay, I'm so sorry. Lime. I'm just gonna write lime. You guys hopefully can do better. And typing it in your notes is a lot easier. All right, the limestone is the oldest. Why? Yeah, it's at the bottom. What would be our second? Exactly, our sandstone. Forgive me. Oh, I hate when PowerPoint does that. It adds random lines. Sandstone. And I'll type this in the notes too, so it looks a little bit better. Third one? Yeah, the shale. And then our fourth is gonna, I hate when it does that. Our fourth is gonna be an event. I'm just gonna write erosion. All right. Oh my gosh, this is, okay. My handwriting's bad enough, PowerPoint's not helping me. I'm gonna pull up the notes. This might make a little more sense than my really, really bad handwriting. Okay. Now I want you guys to give that second picture a shot. Tell me what you think. Do exactly what we just did for the picture number 1. I'll give you a couple minutes. Are you guys good if I exit out of this picture, since you guys have them on your screen? Okay. Yeah, number 1 is the oldest thing on there, and then you're going to work your way to the most recent. All right, take about another minute to submit. Ah, sorry guys, I did not mean to do that. Anthony, where's your other 4? Oh. Oh, I like whoever did this one. Oh, good job, Jose. What's number 4, Star? Number 4. Okay. All right. 1, 2. All right. All right, I'm gonna do it on the word packet so you don't have to see my embarrassing writing. All right, number 1, the oldest is limestone. Good. Sandstone. Hill. And this one. Oh, I like it. So you're on the perfect track. You're actually the closest I've gotten from any student so far. Right here we have a fault boundary. So if you remember back, like Jose was saying, for the convergent, divergent, transform type of stuff, this would most likely, based off the picture, be a divergent, as the pulls away one of the sides of the fault is going to drop the rock down, like it is in that one. So it's just some sort of fault line. That's all we know. Some sort of fault line, not a line. All right. Okay, the next one I'm going to go through really, really quickly with you guys. In fact, you guys don't even have to do it in the Nearpod. You can just do it in your notes. All right, number 3, we've got our same rock types. And what do you see changes with this picture? Yeah, it's wobbly, it's folded up, it's wavy, all that type of stuff. So this would be like mountain building. So it's like the rock getting compressed from both sides, pushing it together and creating mountains and hills. Now, because that folding or that compression affects all 3 layers, it's going to be really similar, where you're still going to have your limestone, your sandstone, and your shale, and you could just put folding, or you could put like compression or something along those lines for the 4th one. Okay. If it had only happened to 2 layers and then we had like the shale on top, 3 and 4 would switch. And we'll talk about that tomorrow or next week, when we get to ones that look more like this. Okay. Any questions on this part of the notes? Okay. Your March Mammal Madness wildcard round was determined Monday night. The next one will be tonight. So I figured I'd put up the rodent recap.
They say that March comes in like a lion and goes out like a lamb. And sure enough, the wind was roaring outside. I had a lot on my mind, so I poured myself a tall glass of milk when suddenly there was a knock at my door. Or more like a beep on my screen.
Hello? Can you hear me?
Hey, just the marmot I wanted to see. I need your help, MC. I'm on the trail of something. Something big. I got 65 suspects. I gotta narrow it down to just one by the end of March.
Wow, that is big.
It is big, and that's where you come in. See, the problem with me is I get noticed because I'm a handsome man, and I also have to stay 6 feet away from everybody. But see, that's where you come in. You and your roving rodent team, you can go anywhere. You gotta be my eyes and my ears and my nose and my tail and everything else for me. You think you can do that?
What's in it for us?
Exposure, duh. Let me rephrase that. How about the satisfaction of a job well done? We might even throw in some snacks.
All right, we'll take the case. Our first matchup of 2021 set rodent against rodent. Folks, it has been a rough year for all of us on this planet. These things happen. The Hopi chipmunk was transported to Rocky Mountain National Park in Colorado, where it began to forage. Suddenly, it was ambushed by the very territorial bull, who began smacking it upside the head. Bewildered chipmunk bolted, leaving the victorious bull as the wild card winner. And so, one suspect has been eliminated, but there are 64 left. Looking at the bracket told me that this case would take us all around the earth, and even under the sea. It was very mysterious. Why were there so many mythological references? Why were so many red animals mixed up in this? And just what is a platyzilla? Follow us as we investigate the mystery of March Mammal Madness. The game is a foot, or a wing, or a fin, as the case may be. Thank you for watching.